You're swimming near a coral reef off the coast of Australia. The water is clear, visibility is good, and you're watching a creature about the size of your hand moving along the bottom. It's bright, almost cartoonish, with bands of green and orange running down its body. It looks harmless, it looks decorative, and then you watch it punch a crab so hard the shell explodes into fragments, and the water around the impact point flashes white for a fraction of a second before the crab's body drifts away in pieces. You just watched something smaller than a banana deliver more force per square inch than a bullet fired from a handgun. The mantis shrimp doesn't look dangerous because we've been trained to associate danger with size, teeth, and speed we can see. This animal has none of those things in the way we recognize them. What it has is a weapon so extreme that every predator on the reef that has survived an encounter has learned to treat it like a live mine. The assumption that small animals are safe is one of the reef's most expensive lessons. If you found this interesting, consider subscribing. We'll be here when you come back. The mantis shrimp comes in two primary variants, and only one of them is relevant to what you just saw. Spearers have long, sharp appendages designed to impale soft-bodied prey like fish. Smashers have clubs. Blunt, rounded, reinforced clubs that look more like hammers than claws. The Smasher's club accelerates at 10,000 times the force of gravity, reaching speeds of 23 meters per second in less distance than the length of a grain of rice. That makes it the fastest strike of any animal on Earth. The club doesn't just hit. It moves so fast through the water that it creates cavitation bubbles, pockets of vacuum that form in the water, because the liquid cannot fill the space fast enough. When those bubbles collapse, they release a second shockwave. The prey gets hit twice, once by the club itself, once by the implosion of physics trying to correct for the speed of the first impact. If the club misses, the shockwave alone can still stun or kill. The force delivered by a single strike reaches 1,500 newtons. That's enough to crack tempered aquarium glass. Enough to shatter a crab shell the way you would crack a walnut between your hands. Enough that aquariums housing mantis shrimp have learned to use acrylic reinforced with additional layers because standard glass will not hold. The club itself is a material science miracle. It's made of helicoidal fiber structures, layers of chitin arranged in rotating spirals that absorb and disperse impact energy without fracturing. Engineers are studying the structure to design better helmets, better body armor, better anything that needs to take a hit without breaking. The mantis shrimp evolved this material millions of years before we figured out how to build suspension bridges. And because the club is part of the exoskeleton, it regenerates completely every time the animal molts. The weapon is self-repairing. You break it, the mantis shrimp grows a new one. Now take that weapon and attach it to an animal that can see things you cannot even imagine seeing. The mantis shrimp has 16 types of photoreceptors in each eye. Humans have 3. We see red, green, and blue, and our brain mixes those 3 channels into the spectrum we call visible light. The mantis shrimp sees ultraviolet, infrared, and polarized light simultaneously. It sees wavelengths we need machines to detect. You would think that 16 photoreceptors would make them the greatest color processors on the planet, but research suggests the opposite. They may actually be worse at distinguishing subtle color differences than humans are. That sounds like a design flaw until you realize what they traded color nuance for: speed. The mantis shrimp processes visual information faster than almost any animal alive. When your entire survival strategy is built on a strike that lasts 1 millisecond, you don't need to see 100 shades of blue. You need to see the shape, distance, and movement of your target before your brain has finished deciding to strike. Each eye operates independently. Each eye has trinocular vision, meaning it can judge depth without needing input from the other eye. Most animals need 2 eyes working together to perceive distance. The mantis shrimp can do it with 1, which means it has true depth perception in 2 simultaneous fields of view. The eyes can move independently. They can rotate a full 360 degrees. The mantis shrimp is effectively looking in all directions at once, processing depth in real time while tracking movement at speeds your brain would register as a blur. This is not an animal that hunts by ambush. This is an animal that hunts by removing reaction time from the equation entirely. By the time you see the strike has already happened. By the time your nervous system registers pain, The mantis shrimp is already back in its burrow, waiting for the next thing that makes the mistake of being nearby. You would think an animal this well-armed would be a roaming apex predator, moving through the reef taking whatever it wants. You would be wrong. The mantis shrimp is aggressively territorial and almost never leaves the area immediately surrounding its burrow. It does not hunt across the reef. It defends a fixed zone with a level of violence that makes most predators look cautious by comparison. If you enter that zone, the mantis shrimp attacks. It does not matter if you are twice its size. It does not matter if you are an octopus, one of the most intelligent animals in the ocean. The mantis shrimp has been documented killing octopuses that wandered too close, not driving them off, killing them. An octopus is a problem-solving predator with 8 arms, camouflage, and enough strength to pull apart shellfish. The mantis shrimp treats it like any other trespasser. 1 strike, sometimes 2. The octopus does not usually survive long enough to learn the lesson. What makes this even stranger is that mantis shrimp are one of the only crustaceans known to engage in ritualized combat with each other. When 2 mantis shrimp meet and both want the same burrow, they don't fight to the death. They take turns. One mantis shrimp will curl up and expose its tail shield, a reinforced plate on the back of its body. The other will strike it. Then they switch. They trade blows back and forth until one of them decides the burrow is not worth it and leaves. It's almost formal. No one dies. No one gets injured in a way that matters. They settle disputes the way humans settle arm wrestling matches, with rules, structure, and an agreement that the fight ends when someone gives up. For an animal that kills octopuses without hesitation, this level of restraint toward its own species is borderline bizarre. It gets weirder. Mantis shrimp form long-term monogamous pair bonds. This is extremely rare in crustaceans. Most crustaceans mate separate and never see each other again. Mantis shrimp stay together. They share the burrow. They share egg care. The male will guard the entrance while the female tends the eggs, and when the eggs hatch, both parents remain in the burrow and defend the young. Monogamy in the animal kingdom usually signals cooperation under pressure, species that need 2 adults working together because one is not enough. The mantis shrimp does not need help. It is one of the most individually dangerous animals in its weight class, and yet it pairs off, stays faithful, and builds something that looks uncomfortably close to a family structure. Evolution does not waste energy on cooperation unless cooperation improves survival. The question is what exactly the mantis shrimp is cooperating against. They also communicate in a way most of the reef cannot see. Mantis shrimp have polarized light patterns on their bodies, markings that shift and change depending on the angle of light hitting them. Humans cannot see polarized light without equipment. Most fish cannot see it. Most predators cannot see it. The mantis shrimp can. They use these patterns to signal each other, a private visual language that operates in a spectrum invisible to almost everything else on the reef. They can coordinate, warn each other, establish dominance, and mark territory without ever making a sound or a movement that another species would recognize as communication. It's encryption by physics, a frequency no one else is listening to. Now, here is where the script turns, and the reef stops looking like a collection of species and starts looking like a system that has reorganized itself around a single animal. Almost every predator that shares a reef with mantis shrimp has developed specific avoidance behavior toward them. This is not learned individually. This is inherited. Fish that have never seen a mantis shrimp before will still avoid them on first contact. Octopuses, which are documented problem solvers and will investigate almost anything, have been observed taking long detours around mantis shrimp burrows, not approaching carefully, not testing the boundaries, avoiding entirely. These are animals that hunt crabs for a living, animals that crack open shells and pull apart prey with methodical intelligence, and they treat a crab-sized mantis shrimp like it is a threat they cannot afford to engage. Fish that would readily attack crabs of similar size will not touch a mantis shrimp, not because they tried and failed, because they never try. The behavior is pre-installed. The reef does not treat the mantis shrimp as prey. It treats it as a hazard. The evolutionary implication here is profound. When a single species is dangerous enough that the entire surrounding ecosystem modifies its behavior to avoid it, that species has stopped being just another animal. It has become an environmental force, a fixed feature of the landscape that other species navigate around the way they navigate around rocks, currents, and drop-offs. The mantis shrimp is not part of the food web. It is a boundary condition. There are over 450 species of mantis shrimp, and they exist in tropical and subtropical reefs all over the world. They have been around for over 400 million years. That predates dinosaurs. That predates trees. The design you are looking at, clubs, speed, vision, territorial aggression, has been functionally unchanged since before most of the animal kingdom looked anything like it does now. Evolution kept experimenting. The mantis shrimp stayed the same. When a body plan works for 400 million years, it means the organism solved a problem so thoroughly that no variation improved on the solution. The mantis shrimp did not need to evolve because nothing else on the reef evolved a counter to it. The arms race ended. The mantis shrimp won by default, and everything else learned to live around the result. What does it mean for an animal to be this extreme for this long? It means the mantis shrimp is not adapting to the reef. The reef is adapting to the mantis shrimp. Size, teeth, venom, camouflage, all of those are strategies animals use to compete. The mantis shrimp does not compete. It occupies, it holds space, defends it with a level of violence that makes competition irrelevant, and everything else just roots around it. This is not dominance through superiority. This is dominance through disproportionality. The mantis shrimp is not the strongest animal in the ocean. It is not the fastest in any absolute sense, but it is so disproportionately powerful relative to its size that size stopped being the variable that mattered. The question stopped being, can you survive an encounter with this animal? The question became, can you afford to find out? The mantis shrimp rewrites the rules of what danger looks like, because it proves that evolutionary success is not about being better across the board. It is about being so extreme in one dimension that nothing else can match you there, and everything else has to adjust. The ocean did not out-evolve the mantis shrimp. The ocean learned to avoid it. That is a different kind of victory. That is the kind of victory that lasts 400 million years without needing an update. And the strangest part is that the mantis shrimp is not trying to dominate. It is not expanding. It is not taking over. It just sits in its burrow, punches anything that gets close, raises its young with its partner, and continues doing exactly what it has been doing since before the continents finished drifting into place. There is something quietly unsettling about an animal the size of your hand that has been functionally unchanged for 400 million years. Evolution kept trying new things. The reef kept changing. Predators got bigger, faster, smarter. Prey developed better shells, better camouflage, better escape mechanisms. The mantis shrimp just kept working. It did not need to get bigger because it was already hitting harder than anything its size. It did not need better camouflage because nothing was hunting it. It did not need to adapt because adaptation is what you do when your current design is insufficient, and the mantis shrimp's design was never insufficient. It was overkill from the beginning, and overkill does not go out of style. The reef treats the mantis shrimp the way you would treat an electrical wire lying on the ground. You do not test it. You do not investigate it. You assume it is live, and you go around. That assumption is survival. That assumption is the result of 400 million years of selection pressure teaching every species on the reef that the animal with the bright colors and the burrow in the coral is not food, not competition, not a puzzle to solve. It is a line you do not cross. The mantis shrimp does not need to chase you. It does not need to threaten you. It just needs to exist in a space, and that space becomes off limits. That is power. Not the power to take, the power to exclude. So what do you do with an animal like this? You respect it. You give it space. You do not assume that because it fits in your hand, it fits in the category of things you can safely ignore. The mantis shrimp is proof that the ocean's most dangerous animals are not always the ones with the most teeth or the longest reach. Sometimes the most dangerous animal is the one that has been so successful for so long that the entire ecosystem has rewired itself to pretend that animal does not exist. And if you are on the reef watching something small and colorful moving along the bottom, the smart move is to do what every predator in that water has already learned to do. You leave it alone. Thank you for watching. If this was worth your time, like the video. Click the one appearing on screen now.